Okay, here's the short version of problem 1A, the diffusion problem, the fluorescence recovery after photo bleaching problem. Again, we start as a 1D problem, so I click on 1D, click on Next. Then I want to go to Chemical Species Transport and Transport of Dilute Species, so I can double click on that. It shows up here, selected Physics, and I go to Next. This is a time-dependent problem, so I click on Time Dependence, and that's best I can do here, and I click on Finish. So I have my problem set up, don't have any geometry yet. So the first thing I'm going to do is to set up my geometry, and I'm going to do this by right-clicking and going to Interval. For interval, I want to have 3 intervals, so I click on Many, and these intervals are going to be at one point it's 0, the second point is 5 e to the minus 6, the next interval is 6 e to the minus 6, and the next interval is 11 e to the minus 6. That gives us a interval of 5 microns, then 1 micron, then 5 microns. I go ahead and build this. Okay. One thing I can do is you can see that I don't see my separate domains. What I can do is go to Form Union, and I can build that union, and I get that. So that just basically connects everything into one problem. So that's one thing I left off of the initial video. Again, we're not going to worry about the materials because we're just going to define the transport of dilute species, so that's shown here. Once I click on that, I can see my domains 1, 2, and 3. So once I get those, I can click the down arrow, and I'm going to define convection and diffusion, the flux, and the initial values. Okay. So for convection and diffusion, I'm going to have 0 velocity. That's already set there. And as I mentioned in the problem, I want the diffusion coefficient to be e to the minus 13. Okay. The diffusion is going to be the same in all 3 of these. Okay. So I'm not going to change that for the different intervals. However, for initial values, for the first and the third domain, the concentration is going to be 1. When I change the concentration to 1, it actually changes it for all 3 domains. So what I need to do is to override this by introducing another initial value. And I click on this initial value is going to be a concentration of 0, and that's going to be in the middle here. And so what I can do is I can click on that, and I can add that to here, and now that's going to be here. So if I go back to my first initial values, you can see that I've overridden that now. Okay, so now I have my diffusion coefficients the same everywhere, but I have a concentration of 1 here, 0 here, and 1 there. Okay, for mesh, you can see it says physics controlled mesh, and I can build that. And later on, I'm going to want to refine this mesh, and I'm going to show you how to do that. Okay, so to finish off this problem, I have a study, and I want that to be a time-dependent study. And as I mentioned, at first we're just going to do this as 0 to 1 in 0.1 increments. Okay, so that's the notation that we're going to be using for that. Okay, so that really has everything I need. I can go ahead and click on equals, and you can see that I have my diffusion, in this problem. One thing you know is that this is very sharp here, so the way to get this to be a smoother, more realistic concentration profile is I need to go back and refine my mesh. So there's a couple ways to do this. If I leave in physics control mesh, I can do that, and then I can go into change the fineness of the mesh, for example, extremely fine, and I can mesh that. So when I do that, I can go back to my study and click on equals. Okay, you can see it's still a little kind of clunky. It's not exactly smooth. What I found is that if I go into mesh and I take it on user controlled mesh, okay, and then click on the size, I can go in and use the extremely fine, or I can do a custom size and make this e to the minus 8. I actually like to do that better. So when I do that, I get my new mesh, and I can go back to study, click on equals, and I get, you can see, I get my initial value, and then I get all of the other values here. Okay, so that's the problem. There's another portion of the problem that asks for looking at what happens after 20 seconds. the way I can change that is by going to my time dependence and changing my range to go all the way to 20 seconds. To make it solve a little bit faster, I'm going to change this to 1 second intervals instead of 0.1, and I'm going to click on equals again and solve this. And there you go. So now we have a full 20-second recovery curve. Okay, so I hope this helps on the first problem, and I'm going to move on to the next one.